Good morning, everyone. This is Mr.Sk.Ali, Assistant Professor, Department of CS, Kalapati Institute of Engineering and Technology. Today, I'm going to discuss a topic, sparse matrix from the data structure. Coming to the definition of the sparse matrix. A sparse matrix is a matrix where we will have many number of zeros and a very few number of non-zero elements. So look at the example. Here we are having a 5 by 4 matrix. That means we will have a total number of 20 elements in that particular matrix. But unfortunately, in this particular sparse matrix, we are having only 6 non-zero elements. So for this particular matrix, normally this matrix, entire matrix takes 20 elements are to be stored. That means if you consider 2 bytes for each integer, 40 bytes are needed to store the entire array, among which we are only utilizing 12 bytes to store the non-zero elements. That means remaining 28 bytes we are wasting to store only the zeros. So to store this particular sparse matrix efficiently, we are having two types of the representations. One is the array representation and one is the linked representation. Coming to the array representation, we will store the row value, we will store the column value, and we will store that particular non-zero value. This particular matrix consists of the 3 headings. Consider this particular example. Here, 0th row, first column. 0th row, first column, we are having 1 value. And then second row, first column, we are having the 5th element. Second row, third column, we are having the element 2. Like this, we will try to store the elements in the matrix representation or in the array representation. Coming to the another way of representing the sparse matrix, that is the linked representation. This linked representation, the node structure will be like this. First one, we store the row value. Second one, we store the column value. And then here we store the data value. That is the non-zero data we will store here. And this is the right pointer and this is the down pointer. If there is any element in that particular row, we link to that right pointer. If there is any non-zero element in that particular column, we store in the down pointer or we represent to the down pointer. Consider this particular example. Here, this matrix is a 7 by 6. 7 rows and then 6 columns, among which there are only 5 non-zero. So that is the 1, -2, 1, -3, and then these 5 non-zeros are to be stored instead of storing all these particular 0 values. Coming to this particular, this is the linked representation of the sparse matrix. The first node, this is the starting node, and then the first node consists of 7 and then 6. This particular starting node represents the total number of rows in that particular matrix. The total number of columns are 6. This is the column header. This is the column header, and this is the row header. Right. So in that, so in this particular example, I am considering the row index or column index starts with the 0. So 0th row, first column, 0th row, second column, 0th row, fourth column, 0th row, sixth column, first row, third row, fifth row, and then seventh row. Here there are no further rows, so I have been nulled this particular thing. Going back to this particular example, right? So I need to store this particular one. So this is the first row, second element, right? So our 0th row, first element. So 0th row, first element has been stored. Next one. So look at this particular minus the 2. Minus 2 is in the third row, first column. Coming to this one. So minus the 2, third row, first column. Right. So in the same way, here in the third row, we are having a 1 where it is a 1, 2, 3, 4. Third row, fourth column, we are having a 1. So this row pointer or a right node, right link has been connected to third row, fourth column, and the value is 1. Similarly, in the fifth row, we are having a minus 3. So the fifth row, second column, we are storing the minus 3, and then coming back, seventh row, sixth column, we are having the 1. So seventh row, sixth column, we stored the 1, and we don't have the right link, and then the bottom link or down link. So we have nulled our